Our next presenter is Ilari Korhonen from the KTH Royal Institute of Technology. His title is still the same, iRODS at KTH and SNIC, Status and Prospects. There you go.
Hi. So this will be just basically a status update from last year. And I'm from KTH, from Stockholm, and we are running iRODS for our national infrastructure in Sweden. And basically we are, I don't know if you know about Swedish HPC, but we are basically a distributed kind of infrastructure in Sweden. So we have many centers, and there is this coordinating body called SNIC, which allocates funding to these centers. And basically SNIC is funding this national initiative for resource data storage using iRODS. And we are partnering up with another center from another university and in the city of Linköping. And basically we are running a distributed infrastructure on top of iRODS with NSC from Linköping University, another HPC center in Sweden. And this work has been going on for some years in different stages and different projects. But in the current form, we went live in 2017. And we basically, during the year 2017, procured the latest hardware installations that we have now. And the startup basically was that we got funding for dual replicated approximately 1 petabyte of storage, which in practice means that we have 1 petabyte in Stockholm and 1 petabyte in Linköping, and we replicate between those resources, or those sets of resources. And we are a bit asymmetric due to reasons. And at KTH we went with this more performance-oriented configuration. So we procured a GPFS solution from IBM called ESS, or Elastic Storage Server. And our colleagues in Linköping went with a slightly different configuration. They are using ZFS, which is also very good. And they went with a very simple kind of software-defined option by using ZFS and just large disk arrays with some servers on top of them. And we were hoping to get a throughput about 24 gigabytes per second, which is very close to what we're actually getting in practice. So basically we are doing this replication asynchronously using the rule engine. And we are basically landing all our files first in the GPFS file systems in KTH. Since we have 100 gigabits throughput all the way from the internet to the file systems. And that gives us basically a very good, nice throughput using the iRODS parallel transfer. And then we asynchronously replicate to Linköping out of band and check some also out of band after the files have landed. So I think I already told you this. So yeah, we are doing everything asynchronously using the rule engine and some bout jobs as well. So in practice we are looking something like this. So we have some sets of resource trees. The main one is at PDC, and we have sets of file systems and sets of GPFS file sets, and we have sets of resources associated with those separated GPFS file sets. And the same goes basically for our partners at NSC. They have different resources associated to different file systems, different servers. And currently we are only running this with one partner, NSC in Linköping, but hopefully later more people would join, more centers would join. And basically we could have more centers in Sweden using this same setup as they currently are with older solution using Dcache. So hopefully we'll be scaling alongside with that in the future. But we are still in the kind of a startup phase with only 1 petabyte. And they are saying only because in Sweden there's like 50 petabytes of parallel file system storage, and we really need to offload it somewhere. And so also at KTH we have integrated with this national setup of ours. We have a secondary local grid at KTH, a PDC. And we of course have federated these two using iRODS federation. And we like to use Kerberos authentication, so we also have federated the two Kerberos realms. Our national Kerberos realm for this SwiStore domain and also the local Kerberos realm at KTH. So our users can be logged in kind of either authenticated via Kerberos to the national grid using their local credentials, or authenticated via the local grid using their local credentials and so on. So this basically allows them to log in from our compute clusters using the iRODS environment module that we have installed. So basically our challenge is that we need offload for our file systems, because we currently have a 5 petabyte DDN Luster set up at KTH, which is well over 90% full currently, and that should be taken care of. So we are hopefully starting to offload some of that data out of our Luster during this fall, when the users get some encouragement to do that. Obviously they would like to keep all their files in a very fast file system, but they cannot do that indefinitely, of course. So we need to encourage them to offload. So basically, to help this, we have been collaborating with the iRODS people, and especially Justin here. And Justin has been developing this Luster plugin for iRODS, which would enable us to basically set up an iRODS resource on top of a Luster file system. And we could be moving files out of band from the parallel file system using the iRODS transfer mechanisms, right? And we have been testing this in a lab file system, not yet in our production file system. And we have some results. And it seems to work. And still we need to improve on it, I think, but we managed to get it working, I think. And we also tested iRODS storage tiering as well, connected to the Luster plugin, and that also works, of course, because it's just another plugin, rule engine plugin. And so a little bit about Justin's work. So it's basically using the Luster changelog functionality, which basically is it's basically an event log of all file system metadata events, and those get basically pushed to a changelog listener, which is basically software written by Justin, which basically ships off the events to the iRODS catalog. And this is basically the same mechanism that has been used by tools like Robinhood, which is basically a Luster policy engine. And there are some challenges as well. The Luster changelog is not entirely without problems, as we have learned. So first things, it slows the file system down a bit, but that's something you need to accept if you want to use the functionality, because it incurs additional metadata rights to the metadata targets. So some performance was lost, not a lot, but some definitely, in raw metadata performance when we benchmarked the setup, compared to running without changelog and running with the changelog. And also, if you have a very fast file system which would generate loads of changelog, you obviously need to drain it of the metadata target, because if you don't, well, then the metadata target becomes full and your file system crashes. or you won't be able to at least change anything. So that's something that needs to be also taken care of. So you need a very fast changelog consumer. And one quick note about some further things we are investigating in. And we at Sweden are also members of this European PID consortium called EPIC. And we are also running an EPIC service at our center. So our people also hopes that we would be incorporating the use of PIDs later into iRODS. So we would be basically having a pipeline from the parallel file systems to midterm storage, and then we could be publishing data out of iRODS as has been shown that can be done. And we can be associating PIDs to those objects. And I was going to have a short demo, but we'll see what happens because there was some problem somewhere in the internet. There was a name resolution issue, but I think I can show you something. So this is basically one of the Luster. Is the font big enough, or should I make it even bigger maybe?
Yeah, that's good.
Okay. So this is one of my Luster servers. And here you can see basically the file system. It's not very big, but like it's what, 168 terabytes. So it's a file system. So it's built on top of ZFS pools. Just basically raw disk devices mapped over an InfiniBand fabric to these servers, and then ZFS pools built on top of those, and those are just the Luster OSTs and MDTs. So we have a test file system, and in iRODS we have a resource for that, which is called Luster test. Which is basically just another file system resource shown from that host mounting the Luster file system. And we have a path in iRODS, which is called Scratch. And basically this iRODS path here is the mapping point where the objects get registered from the test file system. And those are visible in iRODS. And I was going to do a demo, but internet says no. So
maybe we can get it working for the lightning talks.
yeah, maybe, yeah.
Yeah.
So I think I'm done. If anyone has any questions or anything.
So I have a microphone for questions. Anybody have any questions for Ilari? Oh, there they go, in the back. Always in the back. Well, we can get to next. Hold on, one more.
Thank you for the presentation. I have a maybe stupid fundamental question. Is the Luster used as the data storage in iRODS, or is it synced to iRODS?
The data is stored in Luster, and basically the files are just shown as another file system resource.
And the access, like on the HPC, it's mounted as Luster, or is it mounted as, okay, so the metadata is kept up to date from Luster to iRODS.
Exactly.
Okay, excellent. Thank you very much.
Yeah, that's the idea, but the Luster connector is to keep up to date and keep in sync.
So basically you can access the files either from your local file system, or then you could fetch them over iRODS using the iRODS transport.
Is something like that also accessible for local file systems like ZFS?
No, well, you can. There is no synchronization method, as far as I know, that you could use like a ZFS metadata to sync. The files have to be, well, there's the iReg tool that you can basically scan a file system and register. But as far as I know, no work has been done on syncing an existing file system very efficiently, or maybe Terrell knows. better.
I think that's right. All right. I guess we'll let John ask a question again.
You mentioned you're doing replication. How are you doing that? Because on the tree you put up, there was no replication resource there.
Sorry? Can you repeat?
Sorry, you mentioned you were doing replication, but in the composite tree, the example you gave, there's no replica resource. So how are you doing that? Are you replicating everything, that kind of thing?
That's asynchronous job. So basically all the files land at the so-called primary resource, and then once the files are there, they will be shipped to the secondary resource. So because if we would be using the synchronous method, the files would have to be first written to the first resource and then checksummed and then replicated and then checksummed, so the waiting time is quite long. So the user gets a long delay for the file put. So we have to do it async, and we can accept that it's async.
All right. All right, let's thank Ilari. Thank you so much.
Thank you.